In this video, we are going to understand what is a variable and how to create a variable, how initialization works, and what happened behind the scenes in a memory. This is a simple concept, but you know, bit tricky. So please pay attention to that, and let's see what is a variable. As a definition, we allocate some memory and which can capable to hold a value in it, and also we can label to it. In another way, I can say computer reserves some memory for the variable and it gives the name and finally stores a value inside it. So let me explain with a small example. For that, I'm using first writing my library and I'm writing main function. And if you define a function out of a variable out of a function, then that is a global variable. Global variable int variable a. I'm assigning some value to it. Okay, this is how we define a variable, and we give the name. This is the name of the variable, and we assign some value to it, and this is the data type. And we will go in depth what are the different types that available. For this example, I'm using the int. And now let's see what once we define this, then we'll see what happened behind the scenes. So once we define this variable and run the program, it creates a variable and it allocates some memory. So for local variables, like suppose if I define variable in any function, even main is also function, right? So local variable int variable b equal to 20. So this is the a local variable. So for local variables, memory is allocated on a stack. Uh, so the data type of this variable b is int, right? So it allocates 4 bytes are reserved in a stack memory, and generally memory address hidden for us. If you want to know what is the memory address of this variable, then we can use the references. That is the different topic, but for just example purpose, I'm providing this statement or example address of var b. And if you want to see any variable address, then you can simply use this ampersand. This ampersand symbol called as a reference. Reference variable b. We want to see the address of it, this one, right? And std handle end of the line. And I'm saving this and let's see what. So, so if you see address of variable b is this one. Now we understand what is a variable and what happened behind the scenes once we run our program. Okay. Now I'll explain uh, another concept called declaration and initialization. So suppose if you write a variable like this, then this is called a declaration, just a declaration. Okay. Uh, what what it tells or this variable tells compiler that I need int uh, variable C named C, uh, and it just informed to keep or ready with 4 bytes of memory, but it don't do not allocate any memory. This is declaration. Declaration never allocate memory. It just tells to compiler that I need this much of space. Okay, for this integer type. And we have another type called initialization variable D. Okay, and I can write like this. So once you assign a value to any variable, that is called initialization. Okay. There is another difference of using, these are the two styles of, we create a variable, but each one have different meaning or different purpose of it. So if we just declare and it never allocate any memory, but for initialization, it allocates some memory, uh, and it stores this value for this variable. And finally, it named the memory location as variable D. That is what happened behind the scenes. Okay. And there are multiple types of initialization in C++. One is copy initialization, and another one is direct initialization, and third one is uniform initialization. Let's speak. Let's see each one of the difference. Uh, let's take an example. If I write int x equal to 10.5, okay, and int y equal to 20.5, not equal to, okay, this is called copy initialization, and this is called direct initialization. Okay, and this one is uniform initialization. Okay, let me save this one and run. And I assign for int 10.5 and int 20.5. Basically, these two are float values, but we still assign to the int. And let's see what happen once we run our program. Sorry, let me. And I want to display the output of XYZ. So for int, I assigned float, and even for y, this is in this direct initialization, I used the 20.5. Let's see now, after running our program, what happens here. If you observe, sorry, here I just mentioned X only for all. Let me rerun. If you observe the values here we mentioned it as an a 10.5 and 20.5, but our output is giving an integer. Why? Because float value trimmed automatically and it assign or convert into the integer. So now let's do the same thing for the uniform initialization. Let me give the 30.5. And if I run this, then we are going to get error because uniform initialization, yes, you see this error. Uniform initialization do not allow to assign another data type to it. So modern C++ suggests to use the uniform initialization, whereas copy and direct initialization we use in earlier versions, and we can also use here, but this is the problem, and it automatically trims and trims those values, whereas uniform initialization do not allow assign another type of data type uh, to this to the specific mentioned data type. Okay, I hope you understand. So that's why if I remove this 3 point sorry point 0.5 30 point 0.5, now it's going to run properly. We are going to get these values. Okay, and also we got the value of sorry address of B. And another point, when we declare this variable, why initialization is important? Uh, when we declare a variable, there is a chance that it generate generate variable say with a zero value, or sometimes it assign a garbage value, because based on the memory location this variable say C saves, so that garbage value will assign to this variable. So as a good programmer, we always need to declare sorry initialize uh, variable and or assign a value to a variable. So that's all about variable, and we can also in further video we are going to discuss about more about what is static variable and a global variable, and uh, stack variable or variable stores in a stack. We will see the difference between the static and a global. Thank you.